so from the exam I gave last semester, again, the exam will be on next Thursday. You get a cheat sheet, which is useful for regular expressions, but you should know also that, in case you forget, I don't like you being out there in the blind, so I do have a bunch of stuff on the back of the first page that that I find useful for you in case you forget, because that is a lot of stuff. So like the length of something, how to slice a string or a list, right? Same notation there, how to figure out length, how to compile a regular expression object, how to replace one thing that a regular expression matches, right? How to do the substitution, operation, common operators over here, how to open a file and read it, how to write a file, those kind of things. So those are the kinds of things I will be giving to you for free. Kinds of questions that we'll have, I'll have some questions about strings, stuff, right? I have to go through this because we haven't learned dictionaries yet. I might go over dictionaries today, but I don't plan on actually introducing those for the next exam. What does this expression do? Knowing about your slice notations, regular expressions, write a regular expression that matches these strings but not these strings. I'll have some multiple choices on the exam. So like given this regular expression, not multiple choice, but given a regular expression, please check which of these the regular expression matches, So that write a method that parses a given string and replace all phone numbers. Then a bunch of methods like here. Given a string word, return true if word contains the string cat in the middle, but the middle A can be any character. Open up a file that's separated by commas and give me the sum of all the even numbers in here. So standard stuff that you have already basically learned, but simpler versions of it. So again, I have to go through this and remove stuff that's not relevant to this course, like the Excel stuff that I kind of skipped over. I'm going to go over dictionaries, and then we're going to go over, for the last part of the semester, we're going to handle some utilities that we can do with Python, like PDF reading and manipulating, which I find actually very useful. And then also, I once had to, I've used that in my own life to condense something that was multiple pages of stuff into one single page, into one document. So I was printing out one document rather than 100. Right, so stuff like that. But this exam is primarily about lists and strings, right? What's the difference, what's the difference between the maximum and the minimum in this list? Right, something that swaps the end. And then, so there will be a lot of stuff that deal with evens and odds. It won't be nearly this long. I do like to make it I do want to make it shorter, right? But a lot of this will be writing regular expressions, writing files, and manipulating strings. And the writing file will pretty much be mixed with the regular expressions. Okay. To help with that today, we are going to go ahead and I posted the latest homework. I think I made it due sometime next week, so plenty of time to work on this. Now this is a 4-part homework, right? 4 different parts. 10 questions on the first page for writing 10 different regular expressions, so good practice there. Then 2 more regular expression pages. This one, you can write it without regular expressions, but I tell you to use regular expressions. I'm just saying it's possible to do it without regular expressions. And then this one is, and then finally for number 4, we're going to, problem 4, you want to write a password generator. In other words, something that gives you good, easy to remember passwords, or fairly easy to remember passwords. Okay? So I was going to go ahead and get us started out on this assignment. So this one, I want to use the, I'm asking you questions about this dictionary file I've uploaded called words.txt. Let's see, do I have it over here? Words.txt, right? So let me go ahead and copy this over into my workspace. So remember, the big thing about reading a file I'm giving you is that it's got to be in the same directory as all the other stuff I'm messing with. So classroom, ITP. So I'm going to paste this here, right? Words.txt, and then let's go ahead and start by opening in terminal over here and touch. That will allow me to, that's just going to make a new file. Touch regex hw.py. And I just want to help you get started on the first couple ones so you get the idea of how this works, right? So I'm going to do one for you guys, then I'm going to let you guys do the next one, then we'll see from there how much more practice we can use, and then I'll probably start going over the dictionary stuff with dictionary, because I want to talk about something, because I'm going to be using this a lot because we're going to be taking a look at this. Now this is a file that contains basically a lot of words in the English language, as well as stuff that's, wait, did it have cordyceps? I can't. Well, it's fine. It's a big file, right? It's a fairly big file. There are approximately, let's see, 4,500 lines in this, right? So it's a big file, fairly big, but not too big. So let's go ahead and open it up. Open with other application, Guinea. There we go. All right. So first thing I want to do is I'm going to go ahead and make an if underscore underscore name is equal underscore underscore main, just so that I have a main function here. Def, I'm going to go ahead and then have call it part 1, let's call it. Def part 1, so that basically I'll have, that way I'm just keeping it organized, right? Also at the top over here, what I want to do is that for part 1, since that's dealing with words.txt, I'm only going to read the file over here. So words is, so what I want to do is do the following. Words is equal to an empty array, an empty list, right? Got my nomenclature mixed up there. It's not an array in Python, it's a list. So got an empty list here, and now data is equal to word is equal to open words .txt, right? And then we're going to open it in read format, right? And I'm not going to bother using any function like that. I'm just creating the file pointer to go there. So what I'm going to say is for line in data. So for each of the lines, right, this will go through line by line. And if you remember, this file, words.txt, it's separated such that basically each of the files, each line is on its own separate, each word is on its own separate line of a file. So this will essentially read one word at a time. But I want to read it such that I don't get the new line in there, and avoid spaces. So what I'll say is line is equal to line.strip, right? That's how I remove the beginning and trailing spaces. Very, very useful for getting rid of that white space, right? We don't want that part of the word. And then words.append line. And that's it. That will read one line at a time. And just to confirm that I've done it, I'm going to go ahead and say print words and run this madness, right? And here we go. It looks like I've added everything into this file, including Zoroastrian, Zulu, Zurich, Reek, Rack, Wrath, all the words are in here. Great. Okay. So now on the other hand, so let me go ahead and like print out how many there are. So I believe this is not necessarily all the words in the English language. This is 45,000. This is 45,420, right? If I were to instead do my /user/share/dict/American English. Did I memorize it correctly? Apparently, I get like 60,000 more words. Okay. I think what I've got over here, words.txt, is like a Scrabble dictionary, but that's good enough for our purposes over here. So use that file if you don't mind, so that our answers are consistent with one another. Okay. You may get some certain answers, by the way, that are different from your friends based on whatever regular expression. That's fine, if you can figure out why. Okay. So let's start with the first one. I like animals. How many words contain the word cat or dog in them? Right? So let's go ahead and figure out that. So first, let's go ahead and make a regex right over here. Cat, dog. So let's call it cat, dog, regex. Name of a cartoon, I believe. Right? Not the regex part, but the cat, dog part. Go cat, dog, regex. I'll just go cat, dog, regex is equal to re. Oh, I'll have to import re, remember. Import re. re.compile. So we want to see if the word contains cat or dog in it, right? So we need a regular expression for that. So let's start, so that we're starting out pretty basic then. We can do the regex cat or dog. Is that it? Will that work for cat or dog? Okay, well, let's test it out. For word in words, and the reason I have you put it into that list is because we're going to be iterating through this sucker a whole lot, right? For word in words, let's just print out, so let's go ahead and do if cat dog dot regex dot search word, and this is a kind of a cheat. Basically, it's saying anything that is a non-zero or not none. So in other words, if we return anything from that function, it'll be automatically counted as true. So Python has what we call truthiness and falsiness values. So let's go ahead and show you, right? Python 3, we have, so for instance, obviously true is equal to true. That gives us a true, oh, right, capital T. Capital T, true is equal to true. That's right. And 1 is equal to true, apparently. Well, this is because 1 has a truthiness value, is what we call truthy. It's kind of true. It's a non-zero entity. This is because in older programming, this derives from the fact that in older programming languages, there weren't explicit Boolean types, true or false. You would just use 1 or 0. Or you just use 0, or to even save on that, you'd just say 0 is false, everything else is true. Right? So -1, false. 0 is equal to 0, true is equal to 0, false. 1, 2, okay? So apparently, true is equal to 1. What about, so let's go ahead and say if, but this leads to something interesting. If 3 print 3 is truthy. 3 is truthy. So anything that's not false, sorry, anything that's non-zero is truthy. So if 0, print 0 is truthy, and nothing prints out. So anything that's not a 0 is true. It's truthy. So if we put it in an if statement, it will evaluate to true. Okay, the only things that don't are, I think, none and, So we can test with one more thing. If empty string is also not true. It is also falsy. So anything that's a 0 value is false. So anyway, that means I can just say, hey, if cat.dog.regex.search gives me back something, dot group and it finds cat in a whole lot of things. Groups. And then cat, and then, so it's just looking to say, so that just captures the cat out of it. So instead what I want to do is grab the entire thing from it. So let's go ahead and say find all in so how many words, so if I want to get the entire word though, then I suppose that I got to be a bit more specific about this. So in that case, I maybe want to do, let's say, so a word would be anything, a bunch of anythings, followed by a cat or a dog, followed by anything. It's finding a lot of stuff that's cat. Let's go ahead and do, let's go again do search over here. So this should print out, hey, it found, okay, it found dedicated, communicated, cathodes, cataract, advocated. See a lot, oh, there, and there's some dogs. Dogma, dogmas, dogmatic, dogmatism, dogs, and dog, and doggedly. A lot of cat seems to be a much more popular string than that dot. Let's see, dot match. Can we do that? So let me just check what a match object, what I can call from match object. Match regex Python, right? Because this is something that's been bugging me. Control F match. Match objects have search, expand, returns the string, group, groups, group dicts, start, end, span, position, end position. Oh, string. There we go. In other words, if we over here use dot string, this will give us the string that was passed back to it. There we go. In other words, this will give us what word was and tell us. I mean, I suppose it would have been easier to say, hey, if it matched, I could just print out the word. All that for nothing. Okay. So to say what we printed out. So you cat tan. Okay. So we've got a lot of stuff. So my question was, how many of those match, right? So in that case, I'll go ahead and create a count is equal to 0. And then if the cat dog, and then for every word in our words list, if cat dog regex searches word gives us a response back, right? If that's true, if there is a match there. If there isn't, it's going to return none, right? So if it doesn't, it would return none. And none is the special keyword, capital N none, right? None is just a special value, meaning there's nothing there. So if there is something there, print it out. Well, instead of printing it out, what I'm going to do is I'm going to say count is equal to, and actually I can get rid of these leading and trailing spaces now. I don't really need them. If count is equal to, so count is equal to count plus 1. So we just increment count, and we can now say after the for loop. Why after the for loop? Because after everything has been counted. Print there are, and then I'm going to do comma, count, comma, words that that contain cat or dog. So now that comes out with there are 413 words that contain cat or dog. And you might want to call it cat dog count or put it into basically its own function. But the nice thing about it is that we can contain it. Like if I wanted to put it in its own function, this is the way it would look, by the way. Def cat dog is equal to, and we'll take in words, right? And then over here, we'll just simply call cat dog and pass it words. And now it's its own function, so we can organize it, and we don't have to worry about the other one. I forgot colon. Right. And that way we can organize it so we can put the next question over here. So let's take a look at the next question. 4-letter words are supposedly naughty. How many 4-letter words are there? Right? So let's go ahead and I'll start you out. 4 letters. Right? Pass in the words. And now do the same thing. Create a regular expression. Also, you want to call it over here 4 letters, words. Create your regular expression. So I'll get you started off again. 4 letters. 4-letter regex is equal to re.compile. And then the correct regular expression there. And then count how many of those in the list words match that regular expression and print that out. So I'll give you guys a couple minutes to work on that. Yes? It's not in the right directory. Your Python file isn't in the right directory. It's in app data local program. See, that's where it says it is. So the easiest way is where's the TXT is on your desktop. So the easiest thing to do is go click on File, click on Save As, and then save it to where your words.txt is, which is your desktop. That's the easiest way to put it. And again, I've got tons of laptop stickers now, including a lot more wide variety in my office. So if you want laptop stickers, feel free to grab them. What? Because it doesn't like you. Try doing it the same way you did your you had it in Excel, unless you did that on the CSV file, unless you had that on the desktop.
I just saved it and then it worked.
Mm-hmm. All right.
The Excel file's in a different place.
So you can move everything to that same different place. All right. Have people been able to come up with a regular expression for this one? Okay. This one's not a particularly hard regular expression to do, right? We're looking for a 4-letter word. So something that, but it's looking for something that's, so 4 letters in a row, first off, would be /W/W/W/W, right? However, let's just go ahead and like rewrite that as like W4 /W4, right? Exactly 4. However, we are in an issue basically where this would match a 4-letter word, a 5-letter word, a 6-letter word, and so on and so forth, right? Because this says anything that has 4 in a row in it, right? So what we really want to match is beginning and ending. So there's a couple ways to do that. The first way we can do that is we can use caret and $, a notation I have not yet taught you, where this means beginning of line or string, and the $sign means end of string. So basically, caret, begin the string, /W, do 4 word characters, and $sign, end the string. The way I have taught how to do this, though, is instead of using that, is to use the /B for word boundary, right? Start the boundary of a word, such as the beginning of a string or beginning of a line, then do 4 letters, then end it. And then we can basically copy paste this bit over here. This bit's pretty easy. Count 4 words in words, but rather than doing cat dog regex, we'll do 4-letter regex. Search the word. If it has the word, we'll go ahead and print out the word too. Print word, right? And there are count words that contain cat or dog. Let's see. There are count 4-letter words. So now let's go ahead and run it. So there's 2242 4-letter words in this one. And a lot of them are impolite. Weird that. Okay, whatever. Not sure what's going on there. So, although some of them are quite dope. So, yes. Let's see, caret $sign. So I had 2242. Let's go ahead and see. 2236, right? Caret $sign. 22, interesting. So this is one of those instances where I just, let's go ahead and see. Is there anything that is not 4 letters long here? I mean, I'm going through and I'm looking through this. Is there anything that's not 4 letters in here? How fascinating. So if somebody can look through that and let's go ahead and really spam call right now from Hudson, Ohio. I am very tempted. Professor Rosen's guns and ammo. If we can't kill it, it's immortal. They hung up. All right, so anyway, let's go ahead and deal. So okay, so there's obviously yes. From A to Z times 4. Ah, that makes sense. So let's take a look at this. So let's go ahead and do some comparisons. Great chance for us to practice file writing, by the way. Okay, so let's go ahead and let's go ahead and open a file called, I'm going to call it I'm going to call this output, and open is equal to output of 1.txt and we're going to open that with write, okay, because it's got to be a new file we're creating, okay. And now rather than printing the word, I'm going to go ahead and do word dot, so I'm going to do output dot write the word. So write the word plus a new line. Sorry. Write the word and then output dot write a new line, because remember, these things don't write new lines themselves unless it happens to be part of the string we're writing. So all we have to do is write the word, write the new line, and then go through it, and then we say output dot close, right? So that's all you have to do to write a file. You just simply use open, but with a W instead of a R, right? That's all you have to do. Remember, writing files super easy in Python. Use a W instead of an R, and instead of printing, you do open. You do whatever you just opened, the variable name, dot write. The only thing is that it doesn't end with a new line by default, so you just have to add a new line whenever you write something and you want a new line. So let's go ahead and run this and hope it doesn't crash. So there we go. So if I go into this now, if I go into my folder now for the classroom, actually I can just do that over here, right? And obviously since I called it output1.txt, right? So there we go. There's our file 2236. Okay, so let's go ahead and do output 2, right? And let's go ahead and do with the word boundaries over here, boundary, and then I'm going to do that regular expression you had as well. 2242 when we do boundary. And that goes into output 2, right? Be very careful. If you don't rename it into output 2, you're going to get a smaller file. So be aware. Now, I suspect that the reason that you got significantly less, by the way, from doing A to Z is that this includes capitalization, whereas A to Z does not necessarily include capitalization. But let's go ahead and try that out. If you do A to Z, how much does it change if you do A to Z and capital A to Z? I'll do it. A to Z, capital A to Z, right? Let's go ahead and do this as output 3.txt. Yes?
Some hyphenated words that have like 4 letters before or after the hyphens.
Let's see. Ah, interesting. Hyphenated letter. Yeah. So let's go ahead and do this. Sorry, there was a slash there. So boom. There are 13 4-letter words. I somehow doubt that.
I just did the lowercase A to Z. I got
1700. Let's do $. Maybe it needs to be A to Z, like that. 0. 0 4-letter. Oh, because that was looking for 1. Silly me. 4 of them, please. Okay, that didn't work. Oh, I skipped. How did that happen? Yeah, 2246. So 2236. So the same we would get. So let's go ahead and take a look. So I want to compare these two files. So I'm going to go CD classroom, and then I'm going to use a Unix tool to do this. CD ITP. Very useful tool if you're using this. You have this if you're. So let's see. It's diff. Yeah, it's diff. So diff. Man for man pages. Option files. Okay, cool. Diff. Output 1.txt, output 2.txt. Whoops. So what's the difference between these two? Ah! So there is what the difference is. The one with more words contains Bhagavad Gita, Homebrew, Odell. So it considers the apostrophes and the dashes as word boundaries. So that's why. So O'Shea, O'Hare. So obviously the one we want is this caret and then $sign for beginning the line and then ending the line. Make sense to everybody? Because otherwise we would be counting we counted a lot of other things. Let's see. Boom boom. I'm just going through and cleaning up. But that diff file is pretty nice. It lets me know where, stuff is. All right. Let's go ahead and do, so let's go ahead. Number 3, I am scared of pyramid schemes and MLMs. How many words contain hun in them? H-U-N. So go ahead, and that's another easy one, and then I think we'll go ahead and move on to our next exercise after you take a couple minutes to do that one. Yes?
I figured it out. But, so is the output to,
We don't need to do the output file. That will be output to the same directory as that your files that you're in. You don't need to do that output, any of that output.write thing that I was doing there. It's good practice, but you don't need to do it. The reason I was doing it was to compare our output, to compare why we were getting one versus another. And if you end up having a regular expression, and if you end up having that issue with your regular expressions, like, you're comparing notes with your friend and you get 2 different answers, then doing a diff like that might help. Right? So copying the file over and then comparing notes like that. Highly recommend it. I know, it's not too often you get your homework says, hey, you should share your answers with your classmates. But you should totally compare how you did stuff. This one's fairly straightforward. There's no trick questions, nothing about word boundaries or starting the line or ending the line in this one. Just does it contain the word hun in it, H-U-N. So it should match something like hungry or thunder. And I guess as part of my public service announcements to all you guys, besides getting, vaccinated against the mumps, I highly recommend you do that if you haven't had the chance to do that yet. Don't join a multi-level marketing scheme or a pyramid scheme. But I repeat myself. All right. Everybody good on this one, you think? The regex should just probably been HUN. So, all right. So I'll leave that one to you, but I want to go ahead and move on to our next topic, which is dictionaries, which I think is actually like the previous chapter from this one, which is fine. I do things out of order like that in our book, but that's because I feel like dictionaries are a much more advanced topic. Actually, you guys are actually in luck because of the way that we restructured stuff. This is also something the students who are in 1057 are missing out on because they are dealing with C, which means they're busy dealing with pointers right now and dealing with stuff. And we get to deal with hash tables already, even though that's something that my students in 2168 are currently suffering through. Like literally right now, this is the chapter they're learning about the same data structure. Only in Python, of course, it's easier. So let's go ahead and talk about dictionaries. I love these things, if for no other reason that I've done I've sunk way too much of my life into doing distributed hash tables, which are a distributed form of these data structures that live on a network. And in 2168, you learn about how these work and how these magical data structures work. But dictionaries are these super powerful things, right? Lists, and they're a lot like lists. We'll use a lot of the same list notations, except we can't slice them. So to create a new dictionary, we use curly braces rather than brackets. Okay. Dictionary D is equal to blank. And we can use them basically to begin with just to kind of store anything we'd like in them. There's 3 use cases for them, and then I'll get into what those use cases are. Like there's 3 things you explicitly want to use them for over using a list. So, but here, let's go. But right now we can use them as list notation. And the nice thing is that we can treat them like lists where we didn't have to declare the indices for anything. So at index 4, or rather at key 4 is kind of the way, I want to store red. Okay? And then at D27, for the key 27, I'd like to map that to blue. And D1, I'd like to map that to white. Okay, so let's go ahead and do D. So if I ask for D6, right, it's going to give me an error. Tell me key error 6. It's just telling me I haven't created a key yet that is associated with 6. However, if I do D1, it'll give me white, right? Because I asked it to put white in for, right, to associate. If I give you 1, you're going to give me white back. If I give you 27, I want you to give me blue back. I've associated that the key is 27 and the value is blue. D of 4 is red, right? This is so far pretty straightforward stuff, I think, right? If I actually print out the entirety of the dictionary by either just typing D or print D, this is what I get. I get this interesting little thing. 4 red, 4 colon red, which means 4 is the key, red is the value, 27 is the key, blue is the value, and 1 is the key, and white is the value. So 4 red, 27 blue, 1 white. So this allows us to basically create kind of indices, you know, just on the fly like that. And you're like, okay, so what's kind of the point? Well, the point is that I can use anything I want as a key, not just a number. D favorite is equal to blue. And so now if I ask for D favorite again, it's going to give me blue back. Now that's something you don't see every day. So if I say this, by the way, notice now that blue is a value in there twice. 4 goes to red, 27 goes to blue, 1 goes to white, favorite goes to blue, right? This blue and this blue are independent of each other. They're, you know, point is that anything can be a value. Yes?
If I type in blue, is it going to come up D favorite?
No, it does not work that way. It does not work in the reverse. I don't get to go D blue I can't do a reverse lookup like that. I can't say, given a value, what's the key, right? The way it works is that I give you a key, and then you give me the value back. Now, dictionaries are extremely powerful as a result, and we use them in practice for 3 things. Thing number 1 we use them for is for essentially database key-value pairing. In other words, given a customer's email address, I can retrieve all the information that's associated with that customer, right? Keys are typically what we call unique, right? So like if you log into Amazon, notice that you log in using your username, which is your email address, and your password. It doesn't ask you for your real name, right? Because Andrew Rosen, even Andrew Benjamin Rosen, is not a unique name. Let's go ahead and Google Andrew Rosen for a second. Right? Andrew Rosen is a retail executive, CEO of I did not know that about myself. Andrew Rosen, MD. Andrew Rosen, or braces by Dr. Drew. Okay. Bunch of that. Andrew Rosen on MapQuest. Andrew Rosen is known for his work on Breadwinner 27, The Book of Pure Evil 2010, and Porter to Hell. Not me. Dr. Andrew Rosen received his Bachelor of Art degree at work. I get around and do a lot of stuff. Okay. Yeah, so obviously your name is not unique, unfortunately. I'm not special. So hence we don't use that. Instead, we use something that is unique, which is your email address, right, as your username. And typically, that's why you have stuff like ISBN numbers being the way we look up a lot of like textbooks and stuff, because that's a unique. Because basically, you'd probably be unsurprised the number of textbooks have the title Introduction to Calculus, right? So that's why we have the ISBN number for these things. Okay. So the first thing we'll do is basically give you that we might do something like this to store in like Andrew. So we might store like in a database. This might be what's in there. Andrew.rosen at temple.edu. Right, and this probably isn't like stored in there like using this line exactly, but I'll give you the point. Storing the tuple, right? Andrew Rosen, 1234 American Street, state. Let's see. I think the standard way they'd say it is small town. Right, so there you go, small town Washington, USA, right, obviously a fake address there, right, but then the next thing is like other stuff like, but basically you'd store all that data in there, end of line while standing, string literal, right, they'll store all that stuff in there, and so given the username, it's able to instantly pull up that kind of stuff. That's the nice thing about that. Given the key, I'll instantly give you the value, whatever you mapped with it back. Right, so now if I ask for that, if I use that to log into Amazon, then it will give me then you'll get all the associated customer information, including their shopping cart, which is great. Okay, so that's probably not what we're going to use it for. What's more useful for you guys, by the way, is the second use case, which is counting. Dictionaries, as they're called in Python, are fantastic at counting the number of times you've seen arbitrary number of things. And the third thing these things are useful for are categorization. Given a category as the key, we can we can create a list as the value. Basically, the key is the category, and the value is the list of all the things that belong to that category. Right? So let me go ahead and kind of just show that to you, kind of how that would work. Right? So let's create a new dictionary. D dictionary is equal to new. I'm going to go ahead and say D is equal to D threes is equal to empty list. D fives is equal to empty list. D. Yeah, this is getting too big for me to do in here. I'm going to do this out over here. So let's call this over here as a classroom. Data structures. Not data structures. Ugh. Category dict example. Save as arg. Save as .py. Silly Linux allowing me to make stuff without a file type. Okay, so let's go ahead and I'll just put this in here because again I want to be able to do this and make it easy to read. D is equal to an empty dictionary. Let's go ahead and say I'll create a category called threes, and this is going to hold multiples of 3. D is going to hold fives, which is multiples of 5s, and D is equal to 7s, which is gonna hold multiples of 7s. Okay, right now everything is empty, right? Right, 3's empty. There are no multiples of 3, no multiples of 5s, and no multiples of 7s. So now what we'll do is for num in range, starting at 3, going all the way to, let's go ahead and go to 100,000, right? Let's find all the multiples of 3 that are below 100,000, all the multiples of 5, and all the multiples of 7 that are each below 100,000. Just like that, okay? If num mod 3 equals 0, so if the number is evenly divisible by 3, it's a multiple of 3, which means what are we going to do? We're going to do d dot 3s, and that's going to return the list that I just stored in there. Dot append, so we'll add in number to that, and then I'm going to copy it, and then do a paste operation. Because the number can be divisible by 3 and 5 and 7. So and if it's all of those things, it should go in all the things. 5s, 7s, and that's it. And so now if I print out that dictionary, it's going to be pretty massive. So let's go ahead and make it a bit smaller. Maybe we'll take it down to 1,000, right? Still pretty massive. But here are all the 3 numbers that are divisible by 3, all the numbers that are divisible by 5, and all the numbers that are multiples of 7, right? In being categorized into each category, right? Numbers are pretty boring to categorize, at least in terms of Python, but it's a very pretty concrete example. So let's go ahead and actually take a look at like an actual case of something we want to do something that's kind of relevant to, that's kind of similar to the homework that we're doing, right? Now in the homework we're doing, we're saying like how many words there are of some type or another, right? But in this one, let's go ahead and ask which is like the most common or something like that. So let's go ahead and say, sorry, let me save this first. But the problem we're going to look at first is what is the most common letter that words start with, right? The most common letter is E, but which is the most common letter that words start with, right? That seems like a pretty straightforward question to answer, but the more you think about it, it's actually pretty tricky, right? Without dictionaries, right? Suppose we forget dictionaries for a second. How would you solve that? I would have to do something along the lines of, let's see, count words dot word beginnings dot py, right? If I'm using this, then you know, if you don't know about dictionaries, you might go, okay, A is equal to 0, B is equal to 0, right? C is equal to 0, and so on and so forth, making one variable for each of those. right? Although this leads to a pretty wicked if statement in the end, right? Return which is biggest, A, B, C, D, E, F, G, right? So that would be pretty terrible, right? Doable, okay? But suppose somebody tells you there's a newfangled 27th letter that's been immediately adopted by American English for some godforsaken reason, okay? So, then you'd have to completely rewrite your code, or especially if you have to rewrite your code for a different language. So let's try to avoid that, mapping it to another language. Similarly, I could do an L and say, okay, index 0, I'll create 26 zeros. One will be, I can just do that by doing this, right? 26 zeros. The first one will represent A, so whenever I see an A, I'm going to increment index 0. If I see a B, I'm going to increment index 1, and so on and so forth. But that's annoying because I have to keep track of what all those are. Dictionaries make those extremely useful. So let's go ahead and use a dictionary and we'll just call it counts. Okay, is equal to a new dictionary, and let's go ahead and read our read our file. So data is equal to open words.txt, right? Got to put that in quotes. And it doesn't matter. Is our read mode, right? Let's go ahead and do that. Okay, for word in data, for line in data, right? So the first thing I want to do is line is equal to line.strip to basically sanitize it, right? If there's a leading space, I want to get rid of it for some reason. I don't know why there would be, but let's just assume there is. And then, oops, accidentally close that by pressing Control D. So, recent files. There we go. So let's go ahead, line.strip. And then let's go ahead and say line.toLower, or is it dot lowercase? Line is equal to line.lower. Let's go ahead and see if that works. Like, might as well make it lowercase. Okay, right? Might as well make it lowercase as well, right? If it starts with a capital A or a lowercase a, it's the same letter. Okay? So let's go, so now that we've done that, let's go ahead and get the starting letter. Okay? Letter is equal to, so let's go ahead and get letter is equal to line 0, right? The very first letter of it. And now, how do we use this thing? Well, it's time to take a look at our dictionary over here. So let's go ahead and say, let's go ahead and just create a again, we're going to create a dictionary just as a kind of a scratch pad is equal to this. So D1 equals, key 1 is equal to the value 2. Right? You can make anything the key and anything the value you want, pretty much. So let's go ahead and see D. So let's take a look at the in statement, right? We've been able to use that before. 1 in. So let's go ahead. 0 in D. False. It's not in D. 1 is in D. True. Okay, that's pretty useful. 2 in D. False. So what's it checking for? It's checking the keys, right? So, right, 1 is in D, it's saying, because 1 is a key. So just check, so that in statement will check to see if the key is in there. So we can say, so this gives us a way to do stuff. So we can ask if letter is in the counts. So in other words, if letter is in the counts, right? In other words, if I've seen it before, we're going to do something about it, right? We're going to say, I've seen one more of this. Else, if I haven't seen it before, let's go ahead and just figure that out. If I haven't seen this letter before, we want to add it to our counts. So we'll go counts, letter is equal to 1, right? If I haven't seen the letter before, I'm going to say I've seen it one time. Make sense to everybody? But if I have seen it before, what I'll do is I'll say count. I'll get the number of times I've seen it. Count is equal to counts letter. So in other words, I'm going to get the amount of times I've seen it already, right? If it's in count, it has a value associated with it. So I'm going to retrieve that value, store it in count, and then I'll say counts letter is equal to the number of times I've seen it so far, which is count, plus 1. Which I could just simply say this instead. Counts letter is equal to counts of letter plus 1. Right, and that will increment it. And now, let's go ahead and print our dictionary, our counts, to see what we've got. Counts is equal to print counts. So here's our counts. Notice we've got our letters in there. Let's go ahead and print out how many letters we have. Len. So let's see what happens when we do a len on a dictionary. It gives us 26, right? You'd expect there's 26 letters, right? And any word can start with any of those letters, right? So now, which one is the most common? Well, I could look at this and say, well, honestly, there's a lot, and my memory's pretty bad, but it looks like, no, and I keep going, it looks like S is the most common letter that things start with, right? But how could I get the computer to tell me that? So let's go ahead and say most common letter is equal to the empty string, and most common and highest count is equal to 0, right? So what we'll do is that we'll go through all the letters in the dictionary. So for let's see, for X in, so let's go ahead and see what does X and D do. So for X in counts, let's print out X and see what it does first to see how this works. Print X. So it goes through and actually prints them out. They happen to be in order because of what's called a hashing function that basically arranged all those in order. So A, B, C, D, E, F, G. But you'll see that that doesn't necessarily hold for other things. So for X in counts, great, it will go through the keys. So for letter in our counts, if counts for the letter is greater than the highest count, so in other words, if we've seen more of this letter than anything else, letter is, highest count is equal to that number, counts letter, and most common letter is equal to letter. Print most common letter, highest count. And that's it. S5129. Now what I love about this particular thing that we just wrote here is that this formula actually is exceedingly versatile. 18 lines, right? And we were asking for the most common, right? So the most common letter, specifically we were looking for what is the word beginning, right? That's why we got the line 0. We were looking at the first letter, the most common index 0 for each of these strings. But what if I wanted to know what the most common, let's say 2 letters, right? What are the most common letter pair that starts words off? Is it sh or sta, right? Or is it th? Is it th? right? So which of those pairs? Which all that requires me to do is change this from 0, is change that slice to go from just being 0 to 0 through 2, not including the 2. And now I run it, and it says actually that CO is the most common letter pair that starts letters off as, which is very interesting there. What if instead I wanted to go for the most common letter? Just straight out, do a count of the most common letter in this file. Okay? It's not always A, by the way, I should mention, right? The most common, sorry, it's not always E, by the way. The most common letter isn't always E. For instance, some writers and authors have way too much time on their hands. Gadsby was a novel. It's a novel in 1939, written as a lipogram, and it does not contain the letter E. It revolves the dying fictional city Branton Hills, which is revitalized by the efforts of the protagonist John Gadsby and a youth group he organizes. Included in the book, he said his primary difficulty was avoiding the ed suffix for past tense verbs. He made extensive use of verbs that did not take the ed suffix and constructions with do. For instance, did walk instead of walked. Scarcity of word options also drastically limited discussion involving quantity, pronouns, and many common words. He was unable to talk about any quantity between 6 and 30. So he used abbreviations on occasion, but only if it was, valid. If what was being abbreviated was valid. So DR for doctor, PS for postscript, but Mr. would not be allowed. So anyway, that's really just the only reason I bring it up. It's because somebody might mess with you one day with a document like that. So actually, I'm kind of interested in seeing what the most common letter is. Fortunately, because it's left copyright, I can go to Project Gutenberg to get it. Anything that's out of copyright, you should be able to get it at Project Gutenberg. Let's just go ahead. It might not be it might probably not be liking me because I'm trying to get to it with the VPN on. Yeah, so does it not like the VPN or something? Yep. Internet. Yeah, maybe that's it. Or just doesn't like me trying to connect when I'm on a VPN. Why isn't it showing up there anyway? Okay. Gadsby archive. Let's go ahead and go to archive.org instead. They should be able to have a copy as well. Full text. Is that text? Yes. Okay. Save. No, not full text of this. I'd rather save. Yeah, it's saying that it can't get it from Project Gutenberg. Interesting. Again, it's probably because of the VPN I have up. So, turn off. And then, yeah. And then it's blocking my internet access because I've enabled it. I tell it to block my internet access. Off. Okay. So there we go. Try again. There we go. And plain text UTF-8. So anything. So I love Project Gutenberg. You can get all sorts of texts from there. So let's go ahead. I'm going to save this. And let's find out what the most common letter is in this file. In this book. So classroom, ITP, I'll call it Gadsby. Right, because I'm very curious as to how the frequencies change when you ban the letter E. Okay, so one thing I'm going to do is that I'm going to open that file because it does now contain some E's because it's been contaminated by the header. Right, you can't even call it an e-book. Right, there we go. E bar, blah, blah, blah. I can't use E. Right, there's the lipograph, so let's go ahead and just get, so now I've just trimmed out all the text. Let's go ahead and then remove the rights about this, which is that basically that it is a, there, bam. Okay, so there we go. Let's go ahead and read through this file now. Okay, so let's go ahead, count word beginnings. So let's go ahead, I'll go ahead and create a new file for this, right? Counts is equal to semicolon, data is equal to open gadsb.txt, because I went ahead and downloaded that. And you can use any file you want. I just happen to be using Gadsby for this. Classroom, destruct, or sorry, ITP. Let's call this letter count .py. So again, we're looking for the most common letter. Okay. For line in data. For line in data, what are we going to do? We are going to say line is equal to line.strip. And then I'm going to add a dot lower under there as well, so I don't have to do a line dot is equal to line dot lower. So we can do all the conversions we need to over there in one line. Then words is equal to line dot split. Let's just go ahead and do it this way. So we'll go ahead and count up all the characters. This will include stuff like spaces and other punctuation, which is perfectly fine. So we'll just go ahead and then we can remove that later. So for letter in line, if letter is not in count, right? This is another way you can do it. If I've not yet seen it, then counts letter is equal to 1, right? If I've not seen it yet, I gotta put it in there, because otherwise letter counts letter is equal to counts letter plus 1. Print counts. Lines is not defined, it says. So line over there. So if we go through it, let's go ahead and see. We can grab the other part from over here. Most common letter, highest count, right? It's the same deal over here. So I'm just going to copy this from our other program and post it right over here because I use the same variable names and everything. Most common letter, blank. So we get back the most common letter, and the highest count is what? The most common letter is, it says 4,640. This is because actually what it's returning is space. Space is the most common character by far in the English language. It's the most common character because every single word has one after it, unavoidably. So obviously we should probably remove that from the running. So let's go ahead, and the way we do that is we use the del function for delete. And I think I rarely do this, so it's probably you would just do this. Del, and then just put a single space here. D is not defined. Counts. and that will delete so delete is how you remove the del right over there is how you remove something from a collection, like a list or something. So that removed our spaces. So the most common letter, unsurprisingly, after E is A. 23,364 instances of A. Yes?
Can you show that you got the 2 letters?
How I got the 2 letters? Sure. The way I got the 2 letters is the same way I got 1 letter, except just by looking at, it's the most common starting 2 letters rather than just like the most common letter pair, right? The most common starting letter pair. So rather than doing just getting the first letter, I got the slice that includes the first letter and the second letter. So we'll learn more about dictionaries on Thursday. They are extremely powerful data structures. They're extremely fun to work with. And then I think we'll do a nice fun in-class exercise on Thursday that probably doesn't have anything to do with dictionaries. I have a feeling that actually Mad Libs might be helpful for preparing everybody for the exam. So we'll go ahead and see about doing that. All right? So have a great day. And again, I've got more